Okay, let's review for our test of the basic trig functions. To begin with, it's asking sketch an angle in standard position and indicate the quadrant that the terminal side of the angle lies on. If it's quadrantal, say so. Negative 310, remember that we go the other way. So that would be negative 90, negative 180, negative 270, and negative 360. So if we start here, we're going to land somewhere between 270 and 360. So here it is. This is negative 310, which is in quadrant 1. 540 is bigger than 360, so you're going to make an entire, it's positive, so you're going to make an entire loop, one whole loop. And now you're at 360. And then add 100, remember, and subtract, or you're really adding 90. So if you want to do it in your head, 360 plus 100 is 460, and subtract 10. So 450, and then 540. So actually, you land right here on the x-axis, so it's considered to be quadrantal. Number 3, 191. You go 90, 180, right? And a little bit more than 180, not quite to 270. So you're here in quadrant 3. Express each angle in degrees, minutes, and seconds. Remember to use your calculator for that. So you turn your calculator on, and it's already in decimal form. So 45.16. Go to second. Go to second apps. And you'll look at number 4 right here. It says DMS. So you hit enter, and hit enter one more time, and it turns it into degrees, minutes, and seconds. So it's 45 degrees, 9 minutes, and 36 seconds. Okay. I'm going to skip number 5 because it's exactly the same. Going to 12. It's already in degrees, minutes, and seconds, and our job is to express each angle in decimal degree. See the difference? It's in minutes and seconds. So I want to turn it back into kind of like what number 4 looked like originally. So you take 15, you go to second apps, and put your degree symbol right there. Type in 37, go back to second apps, and do your minutes. And then type in 12, and remember our seconds is in a different spot. It's above the plus key. So it's alpha plus. And hit. And then hit enter, and you get 15.62 degrees. All right, now move on to number 8. Name 2 angles, one that's positive and one that's negative, that are coterminal. All right, well, coterminal angles. Well, guys, remember when you have a coterminal, it just means you're lapping around the unit circle one more time. So you would take 120 plus 360 to give you 480 degrees. And then you go the other way, 120 minus 360, which would give you negative 240 degrees. So those are your 2 answers. Same with 280. 280 plus 360, which is going to give you 640 degrees. And then 280 minus 360, which is going to give you negative 80 degrees. Guys, that just is saying that 280, 640, and negative 80, they all stop in the exact same spot. They're just called different things. It just depends on how many times you've wrapped around the unit circle. Now for negative 380, I'm already negative. So look what happens. When I add 360, okay, I end up with a negative 20 degrees. So there's your negative. You don't even have to subtract. You added to get your negative on that one. If you subtracted and did negative 80 minus 360 and got an answer, that would be okay, right? There's nothing wrong with that, but you don't have to. That would have given us negative 740. I most likely will use this one. And then when you take your negative 20 and you add 360 again, you're at 340. So your 2 angles are here. I would accept this one as well, the negative 740. I'm going to skip number 11 and move on. Find the reference angles. Remember, that's the angle that has to be touching the x-axis, right? So let's sketch where it is first. 400. That means I'm going to wrap all the way around to 360, right? And go a tiny bit more. So I'm here. my reference angle, remember, has to touch the x-axis. So it would be here. Right, so if I'm at 360 at this stop and this angle is 400, then the answer is the difference between the two. So 400 minus 360 then is just 40 degrees. So your reference angle is 40 degrees. Don't forget your degree mark. Okay. 155, this is 0, 90, 180, so it falls right here. It's 155. The reference angle, remember, has to touch the x-axis. So it's right here. Okay, if I went to here and got to 155, and I know to close it to the gap would be to 180. So to find it, I would do 180 minus 155. So my reference angle then is 25 degrees. Negative 200 just means, this negative, guys, just means you go the other direction. So you'd say negative 90, negative 180, and negative 270. So you would stop here. Your reference angle, remember, touches the x-axis, and it's acute. So here. Kids get confused because they think the reference angle might be negative, but that's not true. Okay, if this is 180 negative and this is negative 200, the difference is 20. So your reference angle is 20 degrees. You still keep it positive. Right, same with negative 330. Count backwards. Negative 90, negative 180, negative 270, almost to negative 360, but you're here. And negative 330. Your reference angle is here. So from 330 to 360 is 30 degrees. So your reference angle is 30 degrees. Don't forget your degree mark. Moving on. Let's set up these triangles. I think that's where you guys have the most trouble. So remember that we can use SOHCAHTOA. Okay, and this is a negative and a positive. That's in quadrant 2. So I have a point sitting out here in quadrant 2. So to draw my triangle, remember you start at the origin. You go to your point and down to the x-axis. It's important. To your point, down to the x-axis. This is the x value and the y value. Watch your signs. My x value is negative 1, so on the x-axis I'm at negative 1. My y value is root 3. That's how tall my triangle is, so I'm root 3. You have to find the hypotenuse. Use Pythagorean theorem. You have 2 legs. So use parentheses when you square a number in your calculator or you'll mess up. Negative 1 plus root 3 squared equals c squared. If you type just this in your calculator, okay, it's going to do the math. Negative 1 squared is 1 plus the square root of 3, and it drops the actual radical and becomes 3. So c squared is 4, so c is 2. So your hypotenuse is 2. Now on these guys, I'm just going to do some of them just for time. So if I want to find sine, okay, sine is opposite over hypotenuse. I'm talking about opposite of the reference angle, this angle. So if you want to find the opposite, you go from here, opposite. Remember, x is always adjacent, so this is the opposite. So root 3 over 2, the hypotenuse. The cosecant, remember you flip it, so it's 2 over root 3. Okay, and you have to get rid of the radical, which gives me 2 root 3 over 3. Okay, now for cosine. Cosine is adjacent over hypotenuse. Negative 1 over 2. So the secant, you flip it, would be negative 2 over 1, or just negative 2. Remember the little trick I told you about all students take calculus? We're in this quadrant right here. There's our answer. So the only thing that should be positive is sine. So look, positive, positive. Yes, we're good to go. And you'll notice these are negative, and the tangents will also be negative. All right, moving on. Let's look at this one. Negative, negative means it's going to be in quadrant 3. And you'll notice also that only the tangent is going to be positive. All the other answers here are going to be negative. To make your point, you go from the origin to the point and back to x. It tells you this is x and this is y. So you're going to go left root 5 and down negative 3. Don't forget your signs. Now to find the hypotenuse, put parentheses around these things, guys, because of the negatives. Your calculator won't get them right if you don't. So this plus this equals c squared. If you're choosing to use your calculator, you can. I would open my parentheses, negative root 5, close parentheses, square it, plus, open parentheses. Or you can do it in your head. Okay, this is going to drop the radical, and when you square a negative, it turns positive. So that's 5. And this is 9, which gives you 14. C squared is 14, so C is the square root of 14. You check and see if you can reduce that, and you can't. So 14, and I'm going to circle it because it's the hypotenuse. All right, this time, why don't we start with tangent? Let's find tangent. Tangent of your angle, here's my reference angle, is opposite over adjacent. Here's opposite, negative 3. And adjacent, remember, is always the x, so negative root 5. Well, a negative divided by a negative is positive. So I really have 3 over root 5. Let's get the radical out of the denominator. So you have 3 root 5 over 5. And if you use what I taught you over here, tangent is positive. All students take calculus. All are positive, sine is positive, tangent is positive, cosine is positive. So tangent should be positive, and it is. Everything else will be negative. Now then flip. The easiest thing to flip is the first, because if I flip this, then the radical goes in the bottom. Okay, I know it's positive, so I'm going to have root 5 over 3, and that's your answer. Okay. I'm also going to do cosine. Cosine is going to be adjacent, so that's the x, so negative root 5, over hypotenuse, which is root 14. Remember, the hypotenuse is always positive. Okay, to multiply this, you're going to do root 14 over root 14. Kids struggle with this sometimes. If they're both in the radical, they stay in the radical. So 5 times 14 is 70. And this drops. Keep in mind, a negative divided by positive is negative. And remember, the only thing in this whole thing that should be positive is tangent. Okay? Now let's move to the next one. X and Y put me in quadrant 4. So here's my point. Start at the origin, out and up to the x-axis. Do that every time. Start at the origin, out to the point, and to the x. So this is your reference angle. Let's label. On the x-axis, you're going to travel 4. And the y-axis, which is up and down, is negative 1. So 4 squared plus negative 1 squared equals c squared. If you type in your calculator, put parentheses on it. So 16 plus 1, so c is the square root of 17. Now, to check your signs here real quick, I'm in quadrant 4. If you look here, the only thing that's positive in quadrant 4 is cosine. That's because, guys, look, the ordered pair here is positive, negative. Remember, and this is cosine and sine, correct? So the only thing that's positive is cosine. Everything else is negative. So to find cosine, I'm going to do adjacent over hypotenuse. Adjacent is always x, and the hypotenuse is root 17. On here, you have a number outside and a number inside. The outside number stays outside, inside stays inside. And then, this should say 17, I'm sorry. Root 17 times root 17 is just 17. Alright. Now, let's move on to converting. If I want to convert to radians, here's radians, then I write 24 degrees because I'm in degrees. In other words, I'm on my unit circle here. And I'm about right here. And I know that's 24 degrees. I want to know how many radians. In other words, how much of the perimeter have I used? So I do 24 over 1. If I want to write it in radians, I put radians on top. So 2 pi out of 360, right? That's the same thing. So on your calculator, 24 times 2 is 48. Leave our pi, because I want radians, over 360. Now use your calculator, and you can actually reduce that fraction. Just type in 48 divided by 360. Leave the pi there. We want the pi in my answer. Then hit math in your inner, and you get 2/15, which means you're at 2 pi over 15. Okay, now I'm going to show you how to do one and turn it into degrees. So you have 9 pi over 5. This time, you're going to multiply by degrees. If I want to turn it into degrees, degrees goes on top instead. Remember earlier I wanted to turn it into radians, radians goes on top. Okay, the pi's are going to cancel. So you're just going to do 9 times 360, which is this. And then 2 times 5 is 10. Drop the 0. So 324 degrees. Okay, what that means is that if you go 9 pi, if you have a unit circle and you go all the way to 9 pi over 5, which is approximately right here, it's also considered to be 324 degrees. These particular problems, okay, they're a little bit different. They want your 6 trig functions, but instead of giving you a point, they gave you a measure that's on the unit circle, 210 degrees. So if you look at your unit circle, okay, 210 degrees falls right here. It's this point, 7 pi over 6, 210. But it's also this ordered pair. In other words, to get to that point, I had to go left, negative root 3 over 2, and down, right, 1/2. That's how I got there. So you could build yourself a triangle, but what ends up happening, okay, is we went negative root 3 over 2 is your x, and negative 1/2 is your y, and your hypotenuse is always 1, because that's the radius of the unit circle. So when you do sine equals sine of theta equals opposite over hypotenuse, well, look, my opposite would be negative 1/2 over 1, which just stays negative 1/2. Okay, which is written right here, sine. And your cosine is just the adjacent divided by 1, which is just cosine. So the cool thing about this is when you find a degree on your unit circle, just write down the point. So this is negative root 3 over 2, negative 1/2. Okay, which tells us that, if you'll remember, that this is just cosine and this is sine. So sine is negative 1/2, cosine is negative root 3 over 2. Tangent's a little harder. Tangent is y over x, or sine over cosine. So you have to take negative 1/2 and divide by negative root 3 over 2. Right, so we just change our division to times and we flip this, 2 over root 3. Don't forget that it's negative. 2's cancel, and you get 1 over root 3. Which is root 3 over 3. Now, be careful, again, is tangent positive or negative? If you're not sure, all students take calculus. What's the only thing that's positive? Tangent. See, negative, negative, positive. And it makes sense, because a negative divided by a negative is a positive. Now go to 120. Use your unit circle again. Find 120 degrees. There's the point right there. So negative 1/2 root 3 over 2. Cosine, sine. You're in quadrant 2, so only sine is positive. These are the only ones that are positive. Everything else should be negative. And you can look at it by the point too. Cosine is negative, sine is positive. And tangent is a positive divided by a negative. And that's the reason it's negative. So sine is just root 3 over 2. Cosine is negative 1/2. And tangent, okay, is a little harder. It's root 3 over 2 divided by negative 1/2. You have to flip the division to multiply and flip this sign. Choose cancel and you end up with negative root 3 over 1. So you should get negative root 3. If you wanted to find cotangent, you flip this, right? So instead of negative root 3 over 1, I have 1 over root 3. Remember, it's negative. So you have to get rid of the radical. So you get negative root 3 over 3. For secant, you would just flip it. 2 over 1. Okay, and the same goes for these two also. You find them on the unit circle. Okay, the first point is cosine, the second point is sine, and you divide, tangent is y divided by x. Or, in other words, sine divided by cosine. Okay, in class on the back we added a problem, right? And I said that if you're given that sine of theta is 2/3, and then you're going to have to find, for example, let's find cosine and tangent. If you have something that I'm telling you sine is 2/3, remember sine is opposite, so we're going to label this as opposite, over hypotenuse. In other words, if you're going to draw a picture, okay, everything's positive. So 2 and 3 are positive, so you know you're here. Out, down, and over. Opposite is 2. This is 2. Hypotenuse is 3. So you're going to have to mathematically find this. This is tricky. We haven't done many of these. I'm asking you for a leg. This is the hypotenuse. So the formula for that would be 2 squared plus your missing leg equals 3 squared. So 4 plus b squared equals 9. Move your 4 over, so b squared equals 5, and b is the square root of 5. All right, remember, if you have the hypotenuse and the leg, you have to, this is it. You don't add them. You have to subtract, right? 3 squared minus 2 squared. Now then the question was cosine. So cosine would just be the adjacent over hypotenuse. And then to find tangent, okay, it's just opposite over adjacent. Okay, we'll do one last one like that, number 2. If I gave you cosine of theta, it's root 3 over 2, and I want you to find sine of theta, I want you to find tangent of theta. We're going to draw a picture. Everything's positive. Okay, so we're going to be in quadrant 1 again. Cosine is different. Cosine is adjacent. So the adjacent is positive and the hypotenuse is positive. So we're going to go this way. Out and back down. Remember? Adjacent's root 3. The hypotenuse is 2. Again, we're missing a leg. So this is one leg. So root 3 squared plus my missing leg equals my hypotenuse, which I always circle to help me out. Root 3 squared just drops the radical. So 3 plus b squared equals 4. So b squared equals 1. B is the square root of 1. Well, the square root of 1 is just 1. So there you go. So to find sine, okay, sine is opposite over hypotenuse. Here's my angle, opposite over hypotenuse. Remember, adjacent's always x. Tangent would be opposite over adjacent. All right, all done. Good luck on tomorrow's test. Thanks for watching.